Okay, great. So we are looking at session 6 today. Again, it's just a tutorial whereby I'll go through the main points and, where I see fit, I'll elaborate a little more on the various areas, right? So I'm looking to start at the mean, right? Which was one of the things you are really supposed to know in statistics in general, right? So according to this definition here, the mean for a given set of data is the average we had met when we did basic arithmetic, right? So mean and average more or less are the same things, all right? But at this level, we normally call it the mean, right? And if you look on the left-hand side here, the mean or average is written as X bar. That's this X with the little bar on the top. And it's found by summing up the frequency times each observation and dividing it by the sum of the frequencies, which is also known as N, right? Now, some pieces of data, some distributions, they don't have any frequency. Each one of the X values just occurs one time. So all you do is you add up the X values and divide by the number of them there are. But sometimes the X value occur more than one time. So that's when we say we have a frequency distribution, and we use this formula here. All right, so let's see an example, right, on this side. If we go down to, let's see, if we go down to this example here, which is a pretty easy one where you just added up all of these X values here. And that's why you see this funny sign here. It means to sum up or to add up all of the X values. And then you divide by the number of them there are. That's the most basic one. In this case, the mean came out to be 10. But really and truly, right, there is the one that you would tend to get at our level more would be one like this, where there's a frequency distribution. In other words, the marks here are not only one time for each mark, right? You have 0 mark twice, a mark of 1 5 times, and so on, for as much as 23 times. So yes, this is called a frequency distribution, unlike the one that we just did before. In this case, each one of these values here, these marks, which we call the X values, they have a particular frequency because they are occurring, numerous times. Not all of them though, because 5 didn't occur even one time, right? But most of them are occurring more than one time. So there's a frequency. And when you have this scenario here, that's where you use this formula, okay? So let's see how we could use that formula in our calculation, right? So let's say, for example, they told you that you had this frequency distribution here, where a mark of 0 was obtained twice, a mark of 1 5 times, a mark of 2 8 times, and so on. If they had asked you to find the mean or average here, utilizing this formula would have meant that this formula here would have meant that we had to add up all the fx values. So that means we had to find the fx values by multiplying each one of the frequencies by each one of the x values. So 2 by 0 would give me 0, 5 by 1, 5, 8 by 2, 16, and so on. And that's how we would come up with our fx values. So then, according to the formula, we have to sum up. This here means to sum up or to add up all of the fx values. So we would add them up, and you get 494. You add up all the frequencies, right? That's this part here, which is also called n. So we add up all the frequencies, and we would get 100. So in order to get the mean or the average, which we call x bar, which is this x with the little dash on top, all we have to do is divide this figure, the 494, by the 100. And that will give us what we're looking for. Okay? So if we do that, right, if we do that, you'll see the 494 divided by the 100 will give us 4.94. and that would be our mean for that particular frequency distribution. Okay, it's a fairly simple process. All right, the next thing that we're looking at is something called the median. And the median is really defined as the middle or central values in a set of ascending or descending observations. And it is represented by the symbol Q2. The median always has the same number of values above it as there are values below it. Okay, so if you look across here in a nice shortened way, median is known as Q2. It is the middle or central value. What we also need to know is that if you have an odd number of values, then the median will be one number which is located in the center of the distribution once you've put it in a set of, let's say, ascending values. It'll be just that one number if there are odd number of observations, right? Meaning there are 3, 5, 7 observations, you could get the median or the central value by just looking for that one single central value. If, on the other hand, there are even number of values or observations, like 2, 4, 6, 8, and so on, then to get the median, what we have to do is look for the two central values and find the average of those two central values or numbers, okay? That's how we would actually find it. So if we go to a question with the median, let's look at this situation here where they list out for you these numbers, right? It was actually listed out in like this, right, in A, and we have to find the median of the following heights. But if you look at this, it's not in any particular order, neither is this one, right? In this first one, though, there are 1, 2, 3, 4, 5, 6, 7 values or observations. So because that number 7 is an odd number, it means that the median will be one single value. In this case here, there's one more than 7, this one, that means there are 8 observations, which is an even number. So the median is going to be the average of the two central values. So let's look at finding the median of E here, right? What we would have done is we would have taken this and put it into ascending order, or the list that we had for A before, right? This 163, 158, 154, these numbers, they're not in ascending order. So we would have put it in ascending by looking at the smallest number here, which is 154. Then the next larger number after 154 will be 155. Next larger after that in this list is 156. And you go all the way up until you reach 163, putting it in ascending order. Then you look for the middle value. So that middle value, if you locate it, would be 158. Because if you look below that 158, you'd have 3 values. And above it, you'd have 3 values. So that means that you have actually selected that middle value, which is known as the median, right? And if we expected it to be one central value because you had 7 values in all, 1, 2, 3, 4, 5, 6, 7, which means you had an odd number of values. And when that is the case, we learned that across here, if there are odd number of values, only one number could and will form the median, which in this case is the 158 here. In the other one, right, there were 1, 2, 3, 4, 5, 6, 7, 8, as we said. Therefore, when you put it in ascending order like this, we'd have to select the two central values. And these two central values are chosen because below this pair, the central pair of numbers, there will be 3 lower value numbers. And above it, there'll be 3 values that are higher than these two numbers. So to get the median, we'd have to find the average of these two central values, and that could be found by adding them up and dividing it by the total by 2. Or you could just look and see what is halfway between these two numbers, and the answer is 157.5. Remember, that will give us the median, and the median is called Q2, which is yeah, that would be the median, which would be the second or middle quartile. Okay. Now remember, you guys, you should mute yourself. I just muted somebody whose mic is on. You should mute yourself unless you are speaking, right? and then you unmute, speak, and then you mute back your mic because we would be hearing any background noise, okay? All right, so we continue by taking a note of Q2 being the median. Now, why do you use Q2? Well, across here, I give you a little reminder about the Qs. You see all these Qs here? Q2 is included. They are what are known as quartiles. Quartiles divide data into quarters. So there's the upper quartile, which is Q3. There's the middle quartile, which is Q2, and that's what we call the median. And then there's the first quartile or the lower quartile, Q1. Okay, so there's a way to locate these quartiles, right? The median is one of them. And the position or rank of these quartiles is found by using these calculations here. So the median, which is what we were introduced to, could be found by using this calculation. So the median is Q2, so it will be located at this position, 2 over 4 times n plus 1 position, right? The upper quartile, which is the upper part, the largest quartile, is 3/4 into the n plus 1 position. That's where you could locate it. And the lower quartile could be located here. The 1/4, see this one? 1 over 4 into the n plus 1 position. That's how you locate it. So you could use that in these here, right? So let's just go back here and I'll show you how we could use these formulas across on this side here, right? Let's say we were trying to find the median of this first one here, right? Now in this one here, there were 7 digits or 7 values. So n would be 7. So if I took that 7 and I put it here for n to find Q2, or the location of Q2 really, that 7 for n plus 1 would make it 8. And 2 over 4 or a half of 8 would be 4. So this whole thing here would work out to be 4, and then you put th next to it. So that's the 4th position would be where Q2 is. So all you would do is look at this here in ascending order, and you locate Q2 by finding the 4th position, or the 4th term, or the term with rank number 4. So there are different ways to say it: position, rank, or term. So let's look for, when we put this in ascending order, the 4th term. Let's check it out and see what it was. So here it is in ascending order. So the 4th term would be 1, 2, 3, 4. So this is where the 4th term will be, which is the location of Q2. So these things tell you the location. Let's try it on the next one, right? The next one right after this was this one here. So in this case, n, which is the number of values, would be 1, 2, 3, 4, 5, 6, 7, 8. 8 of that, 8 values. So 8 would be the value of n that we'd put in the formula here. So 8 plus 1 is 9. And 2 over 4, or a half of 9, would be 4.5. So Q2 will be in the 4.5 position. 4.5, let's see what that means. And I take this, put it in ascending order, and we're looking for the 4.5 position to get Q2. So that's 1, that's 2, that's 3, that's 4. So the number in the 4th position is 157. The number in the 5th position is 158. So the number in the 4.5 position will be halfway between here and here, which works out to be 157.5. So Q2 would be 157.5, and that is how we can use this information here, which is really the location of all the quartiles. The median is the one that we focused on right now, which is known as the middle or second quartile, and the 2 meaning the second quartile goes on top the quartile, which is the 4, 2 over 4. And that works, that gives you the answer that you're looking for. So let's continue and see what else there is for us to consider here. So that was a major part of it, right? And in this example here, they were giving us that information, which I outlined for you here. In most texts, they don't put 2 over 4, they put a half, but it's very useful to learn it like this, so you'll always remember the formula for upper quartile, which is the 3/4, middle or second quartile, which will be 2/4, and the lower quartile or the first quartile, which will be 1/4. And that will help you to remember the formula. All right. So we're going to learn about something very soon called cumulative frequency. All right. But before that, I want to introduce you or remind you about a table that could help us to understand how cumulative frequency would work and how it could help us to do various calculations. Okay. So in this particular question, they said the weights of 100 pupils in a school are shown in the table below. So what they're saying is 7 people in this school weighed 51 kilograms, 8 weighed 52, 10 weighed 53, and so on. Right, all the way down to 6 students or pupils weighing 60 kilograms. Right, they want us to find the median of the weights shown in the frequency distribution, which means find Q2, and then determine some probabilities. So we will do this question, right, because it reminds us of a few things that we had studied before, and it gives us a good base to work from. Okay, it's a very good question like that. So let's say that we were going to take this information and represent it, right, in a table, because remember Q2 will be, if they want the median Q2, we will have to find a certain position, which is the median position. So let's see how we would find Q2 or the median in all of this, right? One way is to list it out and find the middle value, but where is that middle value, right? That's an important fact. Where would that middle value lie? And we could use this formula here to help us find where that middle value would lie for this distribution, right? And that's what we're going to do. So Q2 is going to be at the 2/4, which is this here, into the n plus 1 position. Now, what is n? N is the total number of values, and they told us the total number of values here was 100. So we're going to use that 100 here for n, right? N is going to be 100. So Q2, which is the median that they want in this question, find the median, is going to be located at the 2/4 into the n, which is 100 plus 1 position, right? Another word for position is rank, right? So 100 plus 1 is 101. So Q2 will be at the 2/4 into the 101th rank. That's where it will be. And 2/4 times 101 is the same thing as a half of 101, which means it would be at the 50.5th position or rank. Remember, we just had looked at one that was in the 4.5th position, which is halfway between the 4th and the 5th. Well, this position here is really halfway between the 50th and the 51st person's weight. All right. So that means I'd have to find the 50th person's weight, the 51st person's weight, and the answer I get, I'll just divide it by 2. And that will give me the what you call the median Q2, right? So to get the person's weight here, this is the calculation we have to do. Now, I could take all these weights and put them in a line and go and check down to the 50th, right? But of course, that will take a very long sheet of paper. So what we could do initially, without any further knowledge, we could write down 7 51s, 8 52s, 10 53s, and so on until we reach the last 6 60s. And it could look something like this, right? It could look something like this, where you write down, 7 51s, 1, 2, 3, 4, 5, 6, 7. Where did I get that from? I got that from here, 7 51s. Then I could write down 8 52s. Right? Let's see 8 52s from here. 1, 2, 3, 4, 5, 6, 7, 8. Right? So the first 7, up to 7 persons, their weight was, all of them was 51. Then the next 8 people, 1, 2, 3, 4, 5, 6, 7, 8, their weight was 52 according to the table. That means they would occupy position number not 7 because the first 7 was 51. They would occupy from position 8, right? 9, 10, 11, 12, 13, 14, 15, right? Up to position 15, they would occupy. And then the next set of weights, which is 53, we write on all of those, and they would occupy all the way up to position number 25. So in that way, we could write down all of the weights and check their positions. But for this question, what they wanted was Q2, which is located halfway between the 50th and the 51st position. And we know that from our formula, right, which we calculated. So let's check what the person's weight would be in the 50th position, right? So position or rank, if you look here, right, here's the person at position 41, position at 42, and so on. This person's here, right? This person's here at position 50. That person's weight is 55 kilograms. So for the 50th person's weight, we wrote down 55 kilograms. For the person at rank or position 51, their weight was 56 kilograms. So that's why for 51st person's weight, I wrote down 56 kilograms. So from this table, we could get, the weight of people in any position. And then when I add them up and divide by 2, or simply look to find the weight halfway between these two, you could clearly see that that weight will be 55.5 kilograms, which really is the median that they were asking for in this question. They asked what is the median weight, and the median weight will be 55.5 kilograms. So that is very instructive. You need to be able to do that. Now, in an exam, you probably wouldn't have time to write down all of this, right? It'll be a bit tedious. And then instead of 100 people, it could be 200, 500, 1,000. So the larger the number, the more impractical it would be to use this method to find the median or any other calculation similar to it, like to find any of these values here. It becomes more and more impractical the larger the number is. So we have to look for an alternate way, and that alternate way means constructing something called a cumulative frequency table and being able to use it to find similar values that we were able to find using this table. Okay, so let's see what this cumulative frequency table is about and how we could use it, right? So a cumulative frequency table basically looks like this here, like this one here, okay? And how that cumulative frequency table really comes about is we use less than or equal to values. In other words, if 7 pupils weighed 51 kilograms, how many pupils weighed 51 kilograms or less? So if you watch this table, it says to us that the smallest weight is 51 and the largest weight when they checked the students' weights was 60 kilograms. So it stands to reason that, of course, if we add up this and when we did add it up, you get 100, then there'll be nobody's whose weight is less than 51 kilograms. And there'll be nobody's whose weight is more than 60 kilograms. So we could say that the number of pupils weighing 51 kilograms or less has to be 7 because nobody weighs less than 51. So we could write that here. 51 kilograms or less, 7. How many pupils weighed 52? 8. So if we ask ourselves how many pupils weighed 52 or less, it would mean kilograms. It means we'd have to add up this 8 and this 7, and we would get 15 pupils weighing 52 kilograms or less. All right. And we could continue doing that. How many pupils weighed 53 kilograms or less, which is less than or equal to 53 kilograms. Hence this symbol, less than or equal to 53 kilograms. You'd have to add the 8 and the 7 and the 10. But remember, we had 8 and 7 already, which is this 15 here. So all you have to do is add 15 and 10, and that would give us the figure required here. Now that process is called forming a cumulative frequency table. And you would need to be able to do that quite a bit if you had to come up with this cumulative frequency. Now, in your multiple choice, I'm not sure if they would give you something to come up with, but in your SB, paper 3, if you're doing it, they could, right? So, you know, I'm just showing you the format. And then we do that all the way until you reach here. How many pupils weigh 60 kilograms or less? And obviously, everybody falls within that range. So 60 kilograms or less, which is this one, less than or equal to 60, would be 100. So this is what we call our cumulative frequency table. But why is this important? Well, this cumulative frequency table, if you make a particular observation, it could help you to do a lot of different things. And one of the things it could help us to do is to find these values here without having to make up that long table that I had to make up previously, which allowed us to calculate this here, right? That is the one that we just looked at. So how could that be done? How could we use this to get the same information we got here? Well, there's an observation that I need you to take into consideration, and that will help us. And the observation is basically this. If I am at, let's say I'm here, and I want to make some deductions, what I have to understand is that from one more than, let's say in this case, 15 is the number here, the cumulative frequency, from position 1 more than 15, which is position 16, all the way to this position, which is 25. So from the 16th person to the 25th person, what we observe, right, is that all of those people, 16 to 25, they're going to weigh 53 kilograms. That's an observation that we made. Let me just write it here so that we will have it and we could talk about it. What is the observation from 16th, right, to 25th? We are saying that according to the observation that I want to point out to you, everybody is going to weigh 53 kilograms. Okay, so let's check if that was indeed so. Let's go back. Let's check that if that was indeed so. We are saying from position 16 to 25, everybody is weighing 53 kilograms. So let's check that. Position or rank number 16, which is here, all the way to rank number 25, everybody is supposed to weigh 53 according to the pattern that I want to make known to you. So let's see if that's correct. Well, from 16, that guy is 53. Just before him, it was 52. So I'm saying from 1 more than 15, which is 16, everybody's going to weigh 53. So that is 16, 17, 18, 19, all of those are 53, 20 is 53, 21, 22, 23, 24, 25, because you say we said up to the 25th position, everybody's going to weigh 53. So up to the 25th, everybody's weighing 53. So hey, that's a good observation. Let's do that experiment another time. Let's see. Let's try it out. I'm going to jump. Let me jump to down here. I'm saying that one more than any one of these cumulative frequencies. So let's say one more than 77 will be 78. So I'm writing that here. 78 rank, one more than 77, all the way down to the 86th rank. So from 77 to 86, everybody in those positions going to weigh this amount, this new one here, 58, right? So we said 78, which is one more than this, to 86, 58. Okay, so let's try that out in our table before and see if that actually is true. So we're looking for the 78 to the 86. So let's look 78, rank number 78, which is here, all the way down to the 86. Everybody's supposed to weigh 58. So 78, yes, 58. 79 is 58. 80th person or 80th rank or 80th positions, 58 kilograms. Let's go down to the 81st person, 58 kilograms. 82nd person, 58. 83rd, 84th, 85th, 86, all the way down to the 86th person. Everybody is weighing 58 kilograms, which is what we are seeing the pattern tells us. So, and if you notice, from the time you go to the 87 person weight, if you put them in order, that person now starts to weigh 59 kilograms. So there's a pattern that we could use when we come up with a cumulative frequency table, which is pretty easy to come up with, that could help us to find the weights of people in various positions, right? So bearing that in mind, if we come back to our question here where we were asked to find the median weight in that distribution, we know we have to find the weight of the 50.5th person, or that's because they want to get the median, which is the average of these two. So what was the 50th person's weight? So according to our theory, let's go back to our theory here. From 1 more than 50, okay, we don't want one more yet, we just want the 50th person's weight. So from 1 more than 37, which will be the 38th person, all the way down to the 50th person, everybody's going to weigh 55. And we are interested in the 50th person or 50th position. So that person is going to weigh 55, which is what we had gotten when we checked it on our previous table. We also need to get the 51st person's weight. So that means that our pattern says that 1 more than 50, which is the 51st person's weight, all the way down to the 65th person, everybody's weight is 56 without looking at the table that we had come up with before. The pattern is telling us that the 51st person, which is 1 more than this, his weight falls in line because 51st to 65, all of them weigh 56. So the 51st person, which is what we're interested in here, he weighs 56 kilograms, and we could write that in. So now we don't need to list out all the weights that they give us. We could come up with a cumulative frequency table, and using that pattern that I just showed you, we could come up with these values or any other values if we had to find any one of these, right? Put it in the formula and work it out and get our Q2 or any other value, Q1 or Q3. Okay, so that's something that a skill you need to be able to use. So in this question too, right, they wanted us to do some other stuff, right? Let's see what other question they wanted us to do. I'm going to enlarge this because we need to talk about it a little more. And as one of the questions in this particular question, they wanted us to find, they wanted us to find the probability that a pupil weighs 56 kilograms or less, right? So the number of pupils who weigh 56 kilograms or less could be found from here. Now, why am I interested in that? Because to find probability that a pupil weighs 56 kilograms or less, we have to find the number of pupils that weigh 56 kilograms or less. That would give us this, the frequency of the observation, and then divide that by the total frequency, which would be the total number of pupils. Why am I referring to that? Because probability, right? Probability is given by this equation, the frequency of the observation we're interested in over the total frequency. In this case, the total frequency will be the total number of pupils, which is 100. And this is the number we need to get for the top, which would be the number of pupils that weigh 56 kilograms or less. Now, in our cumulative frequency table, when we made it up, right, there was actually a value for that. Pupils who weigh 56 kilograms or less than or equal to 56 kilograms, when we came up with the table, we would have gotten that value. It was 65 pupils. So to get the probability that if you choose a pupil at random, he would weigh 56 kilograms or less, we'd have to take the number of pupils that weighed 56 kilograms or less, which is 65, and divide it by the total number of pupils, and that would give you the required probability, right? So I'm just reminding you of what probability is, the formula, and in this case, how to find it, right? That was one. Now, there's an easy one. Let's go down to the next one now. In this one, they wanted you to find the probability that if you chose a pupil at random, that pupil would weigh less than 53 kilograms. Now, if you come here, some people might say less than 53 kilograms is this value, which is 25, and divide that by the total number of pupils, which is 100, and get the answer of 0.25. But that person who did that would have gotten it wrong, because they did not ask what's the probability that if you choose a pupil at random, he would weigh less than or equal to 53 kilograms, which is what this is giving us. They ask what is the probability that the pupil weighs less than 53 kilograms. So less than 53 kilograms will not include it. Less than 53 kilograms will be 52 or 51, which would be this value, less than or equal to 52, would be equivalent to less than 53. And that is 15 pupils would weigh less than 53 kilograms, right? Which would be less than or equal to 52 kilograms. So that 15 is what would go on top here. So the answer would be 15 over 100 or 0.15. So be wary of, little tricks like that, because these are tricky, right? They have a lot to do with your English interpretation of things. All right, so the next one, they said, find the probability that a pupil weighs more than 58 kilograms. Now, because we were looking here all the time, we could kind of forget that we had this table, because this table here gives us the ability to get the more than very quickly, right? More than 58 will be 59 or 60, right? Anybody weighing more than 58 will be those weighing 59 or those weighing 60. The weighing 59 was 8, weighing 60 was 6. So the total number of people weighing more than 58 kilograms would be 8 and 6 added together, which would give us 14 out of or over 100. Because remember, the total frequency, which is what we need to find the probability below here, would be 100. So this would work out to give you a 0.14, right? Now, if you had to get it from here, all you had to do is say, all right, if I need to get the number of pupils that weigh more than 58, and I look right here, and I could see less than or equal to 58 was 86, and there was 100 in all, then if 58 or less, anybody weighing 58 or less kilograms was 86, then the people who weigh more than 58 kilograms will be the remainder, right? 86 from 100, which is 14. The other 14 would weigh more than 58 kilograms. So that's how you could get this 14 here too, right? But of course, it's quite easier, much easier to see it right here, right? To get the 14 answer. But sometimes they may ask you to use the cumulative frequency table, and in that case, that's what you would have done. Okay? Now, the next thing you're supposed to be aware of is something called the mode, right? So let's see what the mode is about. The mode. Let's talk about the mode. Right. So the mode, the mode is the observation with the highest frequency, right? That's the observation that occurs most often. So in these two, you could see the mode very easily, right? If you look at these, which amount of money occurs most often, right? And you notice that the 175 occurs 3 times. There's nothing else occurring more than that. So we say that this distribution, the mode of this distribution here is 175, because that's the number or the amount of money that occurs most often. And because there's only one number that is behaving that way, occurring most often, we say that this distribution is unimodal, right? Look at this one here. In this one, 155 occurs twice, and 160 also occurs twice. There's no other number that occurs twice or more than twice. So it means that 155 is a mode, and 160 is also a mode. So you have 2 modes here. And because you have 2 modes, we say that this distribution is bimodal. If in this you also had, for example, two $200s, $200, then the 155, the 160, and the $200 would all be occurring twice. That means now that you would have 3 numbers that would be modes, or 3 modes, and therefore we say it would be trimodal. Okay, so you should be aware of those terms. All right, we're going to look at something called interquartile range and semi-interquartile range. And I mentioned quartiles to you before, right? On this side, these are the quartiles, right? And a quartile by definition is one of three values that divide an ordered set of data into four equal parts. So I had mentioned to you there was the first or lower quartile, the second, which is known as the middle quartile or the median, and the third quartile known as the upper quartile. These formulas allow us to locate them, they locate their position, right? So let's look at this simple one here. And they said, consider the following heights, which have already been placed in ascending order. If it was not, then you would have to, right? If you want to locate you want to find the quartiles and then find something called the interquartile range and something called the semi-interquartile range, then of course you must have it in ascending order. You could locate the quartile by looking for that middle position. Now, because the number of observations here are odd, 1, 2, 3, 4, 5, 6, 7, odd because 7 is an odd number, right? Once there's an odd number of observations, then the median Q2, which is the second quartile or the middle quartile, will be right smack in the middle, one value. And that, in this case, would have to be 158. Because if you observe it, there are three values below and three values above that 158. So this here, this number here would be the middle quartile or the median, Q2. The lower quartile, which would be the lower half of the data, right? If you consider in the lower half of the data, the lower quartile would be the middle of the lower half of the data. So this is the lower half going this way, and the middle of that would have to be this guy here, that 155. So that would be Q1. What about Q3, the upper quartile? Well, if you consider this as the middle value, then the upper quartile, Q3, is the middle of the upper half of the data. So the upper half of the data would comprise of these numbers here, 1, 2, 3, and the middle value of those would be 161. So that would be Q3, which is the upper quartile, okay? So we could find those by using that technique, or we could use our formulas. Let's go back to the formulas here and see if it could help us. Now, 1, 2, 3, 4, 5, 6, 7 tells us that n is 7. So if we want to find Q1, we could come here, put n as 7 right in this position for n7 here. Let's add 7 and 1 is 8. A quarter times 8 is 2. So it is telling us that Q1, which is the lower quartile, is going to be in this position, the tooth position. Well, it's not really tooth, it's really the second position. The TH is just general. So it's really in position or rank number 2. So let's check out position or rank number 2. There's the first position or rank number 1. There's the second position or rank number 2. The number located there is 155. And therefore, we could have located Q1 by using the formula to get it right here. Q2 would be found by using this formula. N is 7, so 7 and 1 is 8. 2 over 4, or half of 8, is 4. So Q2 will be in the fourth position or fourth rank. 1, 2, 3, 4. And that coincides with what we got. Q3 similarly would be located right here. N is 7, so 7 and 1 is 8. 3/4 of 8. 4 into 8 is 2. 2 by 3 is 6. So it'll be in the sixth position. So let's check the sixth position. 1, 2, 3, 4, 5, 6. Q3 is located there. So very simply, we would have been able to get that as well. So I'm just showing you that these work very well to locate them. And then once you understand that the median is the middle of the whole data, the lower quartile or Q1 is the middle of the bottom half of the data. So it will lie right here. And the upper quartile, Q3, will be in the middle of the top half of the data up here. So very easy, we could find it in multiple ways. But if they wanted to find from here, right, something called the interquartile range, then the definition for interquartile range is this: Q3 minus Q1, upper quartile minus lower quartile. And they could definitely ask you these in multiple choice because they could give you the something very simple like this and ask you to find the answers. So Q3 minus Q1, 161 minus 155 would give me the interquartile range, which is 6 centimeters. And if they wanted to get the semi-interquartile range, it will be Q3 minus Q1, which is the same thing as the interquartile range, simply divided by 2. Of course, S means semi, and semi means half of. Half of what? Interquartile range. So we just find half of that, and you will get your answer. So very easy to get those things. Just remember to learn the formulas, right? Those formulas would help you. All right. So you're going to do the weights of 100 pupils in a school are shown in the table. You want us to find the interquartile range and the semi-interquartile range for this data, right? So let's do that. Okay, so to get the interquartile range, we have to find Q3 and we have to find Q1 and do a subtraction, right? So that's what we're gonna strive to do, find Q3 and Q1. So Q1 is the lower quartile and that is located here, a quarter into the n plus 1th rank or position. Now, n in this distribution was 100. There were 100 bits of data here, right? There's 100 pupils. So what we would have to do is to utilize this to find where Q1 would be. So it'll be a quarter, 100 plus 1 rank or position, which gives you this figure. But what you need to know is that at our level, once you have a fraction, right, whether it be the 25.5 position, 25.25 position, 25.75 position, it doesn't matter. When you do this calculation here, you get a fraction or a decimal here. All we do is we find the average of this number and one more than it. So we're going to find the average of the 25th and the 26th observations. Okay, so let us look at the 25th position, which is right here. 25th position, 53. So the weight of the 25th person is 53. That's how we got this figure here. But remember, we have to find the 26th position as well. How do we find the 26th position? Well, we learned that one more than this number, which is the 26th position or 26 persons weight, right? One more than this, up to 37. So 26 person to 37 person, all of these people will weigh 54 kilograms. That's what we learned earlier. So that's why for the 26th person, I'm going to use 54. So that's how I use this 54. So to get the 25.25th rank, we're going to calculate it by adding up these two and dividing the answer by 2. So that gives us 53.5 kilograms. And that will be our Q1 value, Q1. Okay? How are we going to find Q3 now? Well, we use the formula. This formula here tells us where it is located. So n is 100, 3/4 of 100 is this number. And regardless of what the decimal is, we know we're going to find the 75th person's weight, the 76th person's weight, and divide that answer by 2. How do we get the 75th person? Well, we're going to use these here. So what does it say? The pattern says that one more than the 65th person, which is the 66 person's weight, to the 77 person's weight, everybody's going to weigh 57 kilograms. Now, what we are interested in falls within this range. Remember, it's 66 to 77. We are interested in the 75th person and the 76th person, both of which fall in this range from 66 to 77. So that means that the two people who we are looking for, both of them are going to weigh 57 kilograms. So the 75th person's weight will be 57, and the 76th person's weight will also be 57 kilograms. So we add that and divide by 2. Well, the average of the two numbers is the same thing, right? 57 kilograms. So our Q3 value, or our third or lower upper quartile, sorry, Q3 is going to be 57 kilograms. So if we have to find the the interquartile range firstly, all we have to do is add up these two values, and that will give us not add up. Interquartile range is subtraction, right? So we subtract Q3, take away Q1. So 57 take away 53.5, which is this calculation, 3.5, gives us the interquartile range, IQR. And then the semi-interquartile range is going to be what? Semi-interquartile range is going to be half of that. Half of that will be the semi-interquartile range. So just simply divide the 3.5 by 2, and that gives us the value for the semi-interquartile range that we were looking for. All right, so that would be that calculation. So let's continue downwards and see what else is there. Now we're going to come to something called cumulative frequency curves, otherwise known as ogives. So let's read a little bit here. Cumulative frequency curves. Now for group data, when we draw the graph of a cumulative frequency curve, we obtain a smooth curve called a cumulative frequency curve or ogive. And there are really two ways of drawing cumulative frequency curves or ogives. And to determine which of the two ways that we choose, it depends on the questions that we have to answer. But whenever we draw it, no matter what the question is that has to be answered, the cumulative frequency is always shown on the vertical axis, right? One way of drawing a cumulative frequency curve is by plotting the cumulative frequency on the y-axis against the corresponding upper limit of each class interval. This is done when the words more than or no more than are used in the question. So you must read through the question and see if these words or equivalent words are being used. Or if you can interpret the question to bring these words into it, then yes, we are going to plot the cumulative frequency on the y-axis and the upper class limit of each class interval on the x-axis. All right, of course, we know when we plot it, it's called an ogive, right? Now that's way number one. Another way, which is way number two of drawing the curve, is by plotting the cumulative frequency on the y-axis as usual, and the corresponding upper class boundary now. First one was upper class limit. The second case is the upper class boundary. Two different things. Remember, we had looked at class limits and class boundaries in the last session. So now that is being called into question. So this is done when the words less than or at least are used in the question. So whenever you see these words or their equivalent, or you could interpret it that way, then you are going to use this method here, which is cumulative frequency on the y-axis and the upper class boundaries on the x-axis. Then when you draw your points and you connect them up, you'll get a smooth curve called an ogive. Of course, you could use your French curves, and practice would get you to draw them pretty well. So there's a question here, but before we do the question, let's just look at this summarized a bit. And what I do is to summarize it in this way here, so that I could always have a frame of reference without reading through all those words. So basically, if you look across on the left-hand side here, right, what I have shown you here is that when we are drawing cumulative frequency curves or ogives, they're always going to have this sort of elongated S shape, always. Always, cumulative frequency or CF will be on the vertical axis, which we usually call the y-axis, both cases. This case 1 here and this case 2. Let me just write in case 1 so we'll know this is case 1. And this is case 2, right? So In case 1, which is here, cumulative frequencies on the Y. In case 2, cumulative frequencies on the Y also. But in case 1, what goes along the x-axis is the upper class limits. In case 2, what goes along the x-axis is not the upper class limits, it's the upper class boundaries. All right? You have to understand what is limits and what is boundaries. You can go back and review. I'll be doing at least 1 or 2 examples here so you would see again what they are, right? But notice the distinction, right? Now, how do I know which one to use? Well, when I read the question, if I see these words or their equivalent, or I could interpret them, then I know to draw this option, option 1, which is the words more than or no more than in the question. In this case, I would use less than or equal to values. So less than or equal to whatever the upper class limit is, that's what is going to be plotted here. In this case, case 2, once I see the words less than or at least, then I know I have to put the upper class boundaries on the x-axis, and I'll be using less than values, less than whatever the upper class boundaries are. Okay, so this little diagram here kind of summarizes a lot of what we would have just looked at. Okay. So let's see an example on how we could go about utilizing this information, okay? In this first example, they say a random sample of 60 bulbs is tested to find out how long each will stay alight. And then you record the observation. So basically what they're saying is one bulb stayed lit for between 90 and 99 hours. We don't know the exact thing here. We just know it's within that range, right? 2 bulbs stayed lit for somewhere within this range. 3 bulbs within this range. 5 bulbs stayed lit for somewhere between 120 and 129 hours. We don't know exactly how much hours, but we know within that range, okay? This is group data. And we need to make certain decisions, right? Well, firstly, 60 bulbs is the total number of bulbs, so you could keep that in your mind. They want us to construct a cumulative frequency table. They want us to draw the cumulative frequency curve that comes out of it. And then they want us to determine certain things from it, right? Number of bulbs, probability. All right, so let's go through and see. Firstly, to construct the cumulative frequency table. But we can't construct the cumulative frequency table just by saying that, because we have 2 choices. We need to know which one to do. Should we use the one where the upper class limits is on the x-axis, or should we use the one where the upper class boundaries are on the x-axis? You know, that's a very important question to be answered. In order to answer it, we look here. In the question, we see the words no more than, and even if we didn't see that when we read here, we saw the words more than. And that is telling us in the question, those words, those keywords, right, are telling us that we have to use case 1, which is the upper class limits on the x-axis, and of course the cumulative frequency on the y-axis. So let's see how that goes, right? This is what we started off with. So the number of bulbs that stayed lit for 99, that's the limit, 99 hours or less, would be 1 bulb, which is this, right? So 1 bulb stayed lit for 99 hours or less, which is less than or equal to 99. Let's check here now. How many bulbs stayed lit for 109 hours or less? Well, we'd have to add the 2 and the 1, so that'll give us 3 bulbs. So 3 bulbs stayed lit for 109 hours or less, or less than or equal to 109 hours. Let's check out let's check here now. How many bulbs stayed lit for 119 hours or less? Well, we have to add 3, and what came here? So that's 3, so 3 and 3. 3 and 3 gives us 6. So in that way, by continuously adding the frequency to the sum of the frequencies that went before, right, we get the cumulative frequency all along the way. And when we reach to the end, we are supposed to get the total number of bulbs that were investigated, which we know was 60, right, when you come all the way down here. So basically what we're saying is that the number of bulbs that stayed lit for less than or equal to 199 hours, or 199 hours or less, when we add up all the cumulative frequencies, or everything, sorry, going all the way back here, the frequencies, we should get 60, right? And we did. So now we're going to have to take this information here, this cumulative frequency table, and plot the graph. And our first try graph mightn't come out so good like this, right? But with practice, you would see that your graphs will get better and better. So we came up with our graph. So how did we get this? Well, if we go back, right, less than or equal to 99 hours, 1. So less than or equal to 99 hours, 1. This is supposed to be a little bit higher, but we know that is 1, right? Next one, less than or equal to 109 hours, 3 bulbs. So less than or equal to 109 hours, 3 bulbs. These are the limits. We are using limits here, the upper class limits. Why? Because of the questions to be answered, right? They had the words no more than or more than in it. So we know that's what we have to use here. Okay, and we would plot these things. Let's look at another one. Less than or equal to 129, 11 bulbs. So less than or equal to 129, 11, 10, 11. And we will do that for all of them until we come to the end, and then we draw it out. So that would cover the part where we had to draw the cumulative frequency, right? Firstly, table, and then the cumulative frequency curve, which is known as the ogive. And then they said from this curve now, estimate, the first thing they wanted us to estimate was the number of bulbs that stayed lit or light for no more than 141 hours. No more than 141 hours means 141 hours or less, right? So the number of bulbs that stayed lit for no more than 141 hours means that we have to look for the 141 hours, go up, and come across. And this figure here, the 21, tells us the number of bulbs that stayed lit for less than or equal to 141 hours, which is the same thing as no more than 141 hours, right? So the first answer would be 21, which would be the 21 bulbs here. The second one, they wanted us to work out something else. The second one, they said, find the number of bulbs that stayed alight for more than 165 hours. Now, we cannot find directly more than 165 hours from here because these give us less than or equal to values or no more than values, right? Less than or equal to 99, we had the value here. Less than or equal to 109, we knew the value. We do not know directly from here what they want. No more than, sorry, for more than 165 hours. So what we will do is find what we could get from our graph and then use that to give them the answer that they want, right? Remember, they want the number of bulbs that stayed alight for more than 165 hours, right? So let's find from our graph the number of bulbs that stayed alight for no more than 165 hours, which means 165 hours or less. So we locate that here, we go up, where it hits the graph, where it touches the graph that we just drew, we come across horizontally, and this figure here tells us that there are 48 bulbs that stayed lit for 165 hours or less, right? So I'm going to draw something here, right? 165 hours or less would be these going this way, right? So 165, if I draw a little circle here and I go this way, right? That would be 165 hours or less. And we calculated that would be 48. So 48, right, out of 60 go stay lit for 165 hours or less. Now, we are interested in those that stayed lit for more than 165 hours. So if there are 60 in all, 60 bulbs in all, and 48 of them stayed lit for 165 hours or less, then the remainder, which is 12 bulbs, would stay lit for more than 165 hours, which would be from 166, 167, from here go forward. So that is the answer they are looking for, the number of bulbs that stayed lit for more than 165. Our chart here gives us for 165 hours or less, which is the 48. But now our logic will tell us that, okay, if 48 bulbs are staying lit for 165 hours or less, then the balance, which is 12 out of the 60, would stay lit for more than 165 hours. So that would be the answer they're looking for here, right? 60 take away 48, which will be 12 bulbs. The next question was, what's the probability that a bulb chosen at random stayed alight for 174 to 184 hours inclusive? Okay, so what we're going to do, we're going to find how many bulbs stayed alight for 174 hours or less by coming here, going up, and coming across. So we know 53 bulbs stayed lit for 174 hours or less. That is 53 bulbs. We're going to do the same thing for 184 hours or less. So we come up here and come across, and we realize that there are 57 bulbs that stayed lit for 184 hours or less. So to find the number of bulbs that stayed lit for within or between this range here, between 174 and 184 hours inclusive, we'd have to do a subtraction to see how many bulbs stayed alight within that range. So that would be 57 take away 53. 4 bulbs would stay lit within the range 174 to 184 hours inclusive. Only 4 bulbs. And therefore, the probability would be 4 bulbs out of 60. The frequency we're looking for over the total frequency always gives us the probability. So it's 4 out of 60, or if you cancel down, 4 into 4, 1, 4 into 60 is 15. 1/15 would be the probability that they are looking for. So this was a good question to go over because it covered so many different things that you would, you need to be aware of. Let's continue and go down now to another type. That type was the one where we use the upper class limits on the x-axis. Let's look at one where we use the upper class boundaries on the x-axis, right? So in this question, example 2, they said the frequency distribution of the mathematics marks obtained by 100 candidates is given below. So if you look at this, right, you're seeing, right, 5 candidates score between 1 and 10 marks, 7 scored between 11 and 20 marks, and so on. They say represent the data using a cumulative frequency table. That's okay, we could do that because we are quite good at that, right? We could add up and get our values, right? But we still, not sure if we're using boundaries or limits to come up with our cumulative frequency table, right? We know we have to draw a cumulative frequency curve, right? But which curve? We have 2, option 1 and option 2. We could get the answer for that by looking at here. Now, if you look here, you're seeing questions like calculate from your graph the number of candidates who scored less than 36 marks, the number of candidates who scored at least. So these keywords here, right, which is what we had spoken about before, right, these keywords here, they are showing up. They showed up here. You see less than and at least, right, less than and at least showing up here. So that is telling us we have to use this option here where the upper class boundaries have to go on the x-axis and we're using less than values. So let's see how that would go. All right. So less than values, right? We're using boundaries and not limits, right? What do I mean by boundaries? Well, we're not using less than 10, less than 20, less than 30. We're using less than 10.5, less than 20.5, less than 30.5 because those are the boundaries. Why are we using boundaries? Because the rule says that once these words are present, we use boundaries. All right. So 5 candidates scored less than 10.5 marks because using boundaries. So our table would reflect that. 5 candidates score less than 10.5 marks, right? 7 and 5 is 12. So 12 candidates would score less than, what's the boundary for this? 20.5, halfway between 20 and 21, right? So less than 20.5 marks, 7 and 5 will be 12 candidates scoring that. So 12 candidates scoring less than 20.5. Let's do one more. This is 12 here. So 9 and 12 is 21 candidates would score not less than 30 because we're not using limits. We're going to use in boundaries. So 21 candidates, when we sum up this, would score less than 30.5 marks. So let's check it there. 21 candidates would score less than 30.5 marks. And we continue all the way through until we reach this point, right? So once you get 100, you know that you're correct because they started off by telling you that right here, 100 candidates. So then you would take that information, and you would draw your cumulative frequency curve or ogive. All right, so let's see a couple points. Less than 10.5, 5. Less than 10.5, slightly off, 5. Right? It's supposed to be slightly to the right. If you notice, it's slightly off. Less than 20.5, 12. Is that true? Less than 20.5, 12. Less than 30.5, 21. Let's check that. Less than 30.5, slightly off, 21. It's supposed to be a little higher, right? But all the way through, we plot these points, and then we draw a nice smooth curve through called an ogive using our French curves, right? Make sure and practice it up so you can do those drawings well. Once you have that now, you could start to go and answer the questions, right? We're going to start to answer those questions. So they say from the cumulative frequency curve, you want to get some answers, right? What was the question? The first question there was, represent the data given using the cumulative frequency table, then the frequency curve, we did that, and use your curve to estimate the number of candidates who scored less than 36 marks. Well, that's an easy one because remember, all these are less than values here, right? When we join. So less than 36 marks would be this figure here. We get the figure on the scale. Less than 36 marks, we come up, where it hits the curve, you come across, and you get 28 candidates scoring less than 36 marks. So that would be this answer here. The next question was the number of candidates who scored at least 45 marks, right? At least 45 marks means 45 or more. Now, we cannot get 45 or more directly. What we could get less than 45 marks because that's what this graph is about. These are less than values. What am I talking about? Less than, right? So we can get less than 45 marks. Let's see how many candidates scored less than 45 marks. 44. So I'm going to show that in a diagram that could help us, right? Less than 45 marks was 44. So if 45 marks is here, 44, 43, 42, all the way to the end, and then on the other side, 46, 47, going all the way up, right? This is saying that there are 44 candidates scoring less than 45 marks. So less than 45 marks would be from here, go down. Those who score 44, 43, 42. Less than 45 marks would be these 44 candidates that we got from our graph. But remember, there were 100 candidates in all. So the remainder, 44 from 100, which would be 56 candidates, right? If 44 scored less than 45, then these 56 here would score 45 or more, right? Because remember, on this side was less than 45. That's from 44 go this way. So on the other side, which is the 56 remaining candidates, they would score 45 or more, which is really at least 45 marks, right? At least means 45 or more. So the number of candidates who scored at least 45 was 56 candidates. And that's how you got the answer here, as 56 candidates. So that was a nice one as well. Let's go down to the next one. They said, what would be the pass mark if 45% of the candidates are to be successful? Now, if 45% are to be successful, it means the remainder, which is 55%, would be unsuccessful. That would mean they would fail. So if 45% pass, then 55% fail. Now, what's 55%? Well, if it's 100 candidates, it'd be 55% of 100, as in this case. But sometimes it could be 200, 240, 60, you know, it all depends. But in this case, it's 55% of 100 candidates, which is this calculation, and that gives us 55 candidates failing. Now, 55 candidates failed, that means they got less than the pass mark. Let us go on our cumulative frequency and see what is the mark that 55% of the students got less than, because remember, these are less than values here. So if we get 55 candidates here, students, let's see what mark they got less than by going in this direction now. We're going in the opposite direction that we normally go to, because this mark here would be the mark that these 55 students got less than, because remember, these are less than values. So 55 students got less than 51 marks. So let's take a note of that. 55 candidates got less than 51 marks from our table. That would say that the pass mark had to be 51, because remember, 51, in this case, 51 students got less than, 55 students got less than 51 marks, and the pass mark would be the mark that the students got less than. So from the curve, 55 students got less than 51 marks, and we know 55 students had to fail, and they had to get less than the pass mark, so the pass mark had to be 51. So the answer in this case is 51 marks is the pass mark, right? Because 55 students got less than that, and we know 55% of the students failed, so therefore this had to be the pass mark here, because they got less than that and they failed. The next question, right, is a lot of words, so you have to really think about it. The next question said, calculate the number of candidates who would fail if at least 55 marks are required to pass. Okay, so if at least 55 marks are required to pass, right, then the pass mark is 55. So if you get less than 55, you would fail. So from here, let's see, right, how many candidates got less than 55, because we know those will be the ones who failed. So remember, these are less than values. So less than 55 marks, how many people? 60. So 60 people got less than the pass mark of 55 marks, and therefore 60 people failed. All right. So again, a lot of words, but you have to use your logic. This is like comprehension, is the English, a lot of English and the maths here right now. Okay. So the next thing we're going to look at is some approximations, right? So I'm going to show you what I mean by that, right? For group data, the calculations that we had up here, they become approximated, because for group data, what they're saying is that the total frequency, right, n is so large, right, it's normally when n is greater than 100, then the median Q2 and all the other quartiles, they could be found out or calculated by forgetting about this +1, because n is so large that the 1 doesn't make any kind of impact on it. So instead of, for example, Q2 being 2/4 or a half into the n+1, it becomes 2/4 into the nth position. So, right? So 2/4 or a half nth term. So I'm going to write some things here for you now, right? If you have group data, so I'm going to write it right here, group data, right? These formulas become, right? For example, Q3 becomes 3/4 nth, right? I'll just put rank, because the 1 disappears, it is no longer significant. Q2 becomes the 2/4 or the half nth rank, right? Very important. And Q1, which is a quarter, it becomes nth and not n+1 rank, okay? So that's something you need to remember for group data, right? When you're estimating the median and so on, that becomes your formula to be used. All right. And your interquartile range and your semi-interquartile range calculations remain the same, even though these values here become these, right? You still use the same calculation for the interquartile range. For example, the interquartile range is still going to be Q3 minus Q1, right? It's just that Q3 will be found now by using this formula and Q1 by this formula, right? And your semi-interquartile range, is going to be the same as it was before, which means you take the same Q3 minus Q1 and divide it by 2. Okay, and that's how you're going to get your semi-interquartile range remaining even in these cases for group data. So let's see an example of that. They say a survey was conducted in a school and the masses of the students are shown in the table. Okay, so draw a cumulative frequency curve to represent the data, and from the curve estimate the median mass of the students and then a probability. All right, now you see the words more than, that means that you have to use option 1, which is where we have the upper class limits on the x-axis. All right, so limits, all right, so less than 29, less than or equal to 29, less than or equal to 38, and so on, and you use your cumulative frequency as we would have normally done before. So you see an n value is 200, right? And if they ask us to find the median in this, after we draw our cumulative frequency curve, just as we would have done in the last two, if they ask us to find the median, then how do you go about finding median? Well, you have to use your formula. Q2 is located at the half nth rank or position. But remember, n in this case was 200, right? When we added up and we did the cumulative frequency table, we found at the end, for the last value, it was 200, so that would have been n. They didn't tell us what it was at the beginning, which is a little different to what we had before, because all of the other examples, they were telling us the total number of students. Here, we had to wait until we did all the cumulative frequency calculations, and right here, we got the value of n, and that is how we could find our Q2 location. So Q2, because this is group data, right, Q2 is found by using this formula. So when we put the 200 here, the Q2 is going to be located at the 100th position, or it's going to be the 100th person's weight, right? So, or mass. So all we do is the 100th person will be this person here. We go across and we come down, and the value that we find here is going to be our Q2 value, because this is where Q2 is located. It's the 100th person's weight. And that weight here corresponds to a weight of 52 kilograms. So we could have gotten our answer there as 52 kilograms from the curve. Right? The other calculation, you guys could look at it. I just wanted to mention that if you want to get the mode from group data, right, what you do is you do a histogram. So for example, if you wanted to get the mode, right, for this group data, what is the mode? What the modal interval, right, or the interval or the modal class will be the one that has the most students in it. So this will be the modal class right here, 55 to 59, right? The modal class is the 55 to 59. But to estimate the modal mass, right, that's where the little knowledge comes in. I don't know how many people will know this. If it comes in the exam, you all might be one of the few. But if you want to get the modal mass, which is within this class here, which mass out between 55 to 59 did most students have? Was it 55? Was it 56? Was it 57? Was it 57.5? Which one within this range did most students have? That is what I mean by the modal mass. And so what we do is we plot a histogram using the boundaries, right? You guys are supposed to know how to find the boundaries for each one of these intervals. Each of these are the boundaries. So you use that and you draw your histogram. And when you draw your histogram, the tallest one, right, this tallest bar here will be the modal class. But to get the modal mass, what you do is you connect the right-hand side of the column to the right-hand side of the column nearest it on the left-hand side. And then you connect the left-hand side of the tallest column to the left-hand side of the column closest to it on the right-hand side, which is this point. And where those two lines intersect, which is right here, you're going to draw a line parallel to the y-axis coming straight down. And this value here will be the modal mass. And in our particular situation, it worked out to be 55.5 kilograms. Okay, so this is something they could give it to you. Draw this histogram on your multiple choice and tell you, okay, calculate or find from it what your modal mass would be. And you would just have to connect these two lines and draw a line vertically down, and they might give you a gradation here, and you have to pull the information there. So that could come easily as a multiple choice. It's just that many people wouldn't know what to do. All right, so you guys are among the fortunate ones and the wise ones. All right, so as a reminder, which I just told you, for group data, the lower quartile will be this, where the n plus 1 becomes n. The upper quartile, 3/4. The interquartile range still remains, as I mentioned, and the semi-interquartile range still remains, as I mentioned to you. All right. The next thing we will go on to is something called standard deviation, right? And let's see what we have to say about standard deviation, right? Standard deviation is a commonly used measure of spread or dispersion, right? In calculating this standard deviation, each observation is taken into account, and it is therefore the most mathematical of all the measures of dispersion. Standard deviation is a measure of the spread of individual observations from the mean of a set of data. So let's see, right, some examples with standard deviation. So the first thing I want you to be aware of is that the symbol for standard deviation is S. S is standard deviation. Now, another way of saying standard deviation is like this. It's the RMS deviation from the mean, right? So it's very important, right, to remember that you always need to calculate the mean or have the mean given to you if you have to find standard deviation. Okay? So the RMS deviation from the mean, RMS means the root mean square deviation. Root or square root of the mean of the square of the deviation. What is deviation? Deviation is D. It is x minus x bar, or each x value you have minus the mean of the distribution. And then you put it into this formula and you could get your standard deviation. So let's look at maybe a couple of them and see how we do it. Right, we're going to go to this one here, right, which is the formula that I have here. So the formula that we're going to use for standard deviation in our example is that the standard deviation S is the square root, right, of the sum of the frequency F times D squared over N, where D is the deviation, and we could find that deviation by taking each X value and minusing the mean from it. N is the total number of observation, and you get that by summing all the frequencies, okay? So let's go to our example and we will see how to get this done. All right, just a second. All right. So we are looking at our example. They say the masses of 10 people measured to the nearest kilogram are as follows, right? I wanted to do something for you that has a little more spunk in it. Let's do this one. Yeah, this one has a little more spunk in it, right? 78. Yeah, let's do this one. This one has a little more information in it, right? So the frequency table below shows the distribution of marks in an exam. So you have your mark, right? And you have your frequency. Good. And we are going to find the mean and the standard deviation of the marks. Now, they may not have told you, I'll move this across a little bit more so it's a little bigger, right? So we're going to calculate the mean and the standard deviation of the marks. But even if they didn't say to calculate the mean, you're supposed to know that you have to calculate the mean first. So how do we go about calculating the mean? Well, our formula, which we had learned since the last time, it was the sum of f times x over n. That is the calculation for mean when you have a frequency distribution, right? So we take our original table, which was a x and a frequency, right? If we go here, we'll be able to see it was mark and frequency. So we took the marks and the frequency and we put them vertically, marks and frequency. So we wrote down the marks, we wrote down the frequencies. And in order to get our mean, which is this part, all we have to do is to sum up all of the fx values, okay? So we multiply our f times our x. So 1 times 0 is 0. 4 times 1 is 4, all right? 4 times 2 is 8, and so on. Let's expand this a little bit so you can see it, right? 5 times 3 is 15. 8 times 4, 32. So we got our fx value. So we have to sum, this means to sum them all up. We get 300, right? We have to sum up all our frequencies, get 60. And when we divide these two numbers, the sum of our fx divided by the sum of our frequencies, which is n, that'll be 300 divided by 60. That gives us 5 marks, which will be our mean. So that will take care of this part here, the mean. Right? Now to get the standard deviation, this is the formula we're going to use. All right? So what it means is that taking this mean, we're going to have to use that to get our deviations in our calculation. So the first thing we're going to do is get our deviation. So if this is our x values and our frequencies, right? To get our deviations, we're going to take our x value and subtract the mean from it in each case. So this will be our x value 0, take away your mean or your average x bar of 5. So 0 take away 5 is minus 5. X, which is 1, take away x bar, which is 5. So 1 take away 5 is negative 4. 2 take away 5, negative 3. 3 take away 5, negative 2. 4 take away 5, negative 1. 5 take away 5, 0. So all of these x values, we're going to subtract our mean from it, and that is going to give us our deviation. So in case you're wondering what deviation is, it's the number you get when you take each of your x values and you subtract your mean from it, right? So that's your deviation. But we have to square it. You see deviation squared, so we have to square it. So when we square minus 5, we will get 25. Minus 4 squared, 16. Square this, 9. Square minus 2, 4. Squaring all these would give you these values. Then we have to take the deviations that we squared and multiply it by the frequency. So we're going to take all of these and multiply it by our frequency. So it'll be 1 times 25, 25. 4 times 16, 64. 4 times 9, 36. And in that way, when you multiply them out, you're going to get your FD squared values, which are these. But to get standard deviation, we have to sum up. This means to sum up in statistics. Sum up all your FD squared values. So we have to add up all of these, sum them up. And that will give us a summation, when you add it up, of 292. So that gives, this top part is 292. We know n is the summation of all of these frequencies, right? That's what is n, and that's 60. So what goes below here is the 60. Then when we divide these two, we get 4.87. And then the last step is to find the square root of this 4.87. And that will be 2.21, which gives us our standard deviation. All right. If they had asked for the variance, we would have stopped right here. 4.87 would be the variance, because the variance is the same thing, right? Variance is the same thing as our standard deviation squared, right? So I could write that variance, just for a little information, right? It's the same thing as standard deviation s squared. So if we wanted to find standard deviation, that is why we are going to do the square rooting part, okay? So we're gonna do our square rooting part here now, and that gives us the 2.21, which is our standard deviation. Okay, so that's how you get standard deviation. It's the best example that you can get because it gives you a good rounding off. There's something else you need to know, which is that in standard deviation for group data, because sometimes you get group data, right? The one that we did just now was not group data. This was normal data, 0, 1 to 3. But anytime you have intervals like 0 to 10, 11 to 19, 20 to 29, that's group data. Anytime you have that, then you have to make a decision what you're going to use to represent the data. Is not like here you have one value. You have to get a value to represent each interval in your group data. So what we do is we're going to know that for group data, we use the midpoint of each class interval to represent that interval and proceed as usual. So I'm just going to show you what we mean by that, because there's an example here where the frequency table shows the distribution of heights of 100 students in a school. Estimate the mean height and the standard deviation. Well, for both the mean and the standard deviation, right, we have to use the midpoint of all of these to do these calculations. So for example, we'd have had to find the midpoint of 140 to 144, which is the 142. The midpoint of this, 147. The midpoint of that, 152. And then we use this in the calculations as we would have done for the normal sort of data that was ungrouped data. So for example, in the to get the mean, we would first take this, multiply it by the frequency, right, to get our fx value. So 6 by 142 would give me 852. 10 by 147 would give me 1470. That would give me all my fx values. I would add them up and divide that by the sum of the frequencies, and I would have gotten my mean. So to represent each interval, we use the midpoint. And similarly, when we're doing the standard deviation, to represent this in all our calculations, we're going to use the midpoints here, right? So for example, to get the deviation, we would use this value, which is the midpoint of this, and say x minus x bar would be 142, take away the x bar that we just got, 158.7, and that would give us the deviation for this one. The midpoint of this is 147, so to get the deviation, it will be 147, take away 158.7 to give us this deviation here, and so on. And then we would proceed with the calculation as we would have done in the last one. All right, so that's a very important one. The last thing we do this evening is to take a brief look at the starting of matrices. And there are certain key things we want to cover in matrices, right? And those key things, of course, would be firstly the order of a matrix, right? I'm just trying to get this back here. Okay. Let me just move this out a little bit, right? All right. So the order of the matrix is quite important, and that would be the number of rows by the number of columns, right? We must know how to add and how to do some scalar multiplication. So very quickly, the order of the matrix is the number of rows by the number of columns, and they call it m by n, right? So in these matrices, of course, all of these are known as elements. These are the rows and these are the columns. So in row 1, you have A and B, and in row 2, you have C and D. In column 1, you have A and C, and in column 2, you have B and D, right? The order of this matrix is 2 rows, 1, 2, by 2 columns, right? So those are fairly simple things. The order of this matrix here is 2 rows, 1, 2, by 3 columns, 1, 2, 3. So 2 by 3. The order of this matrix, a strange one, is 3 rows, 1, 2, 3, by 1 column. So we say it's a 3 by 1. The order of this matrix is 3 rows, 1, 2, 3, by 2 columns, 1, 2. All right, so you see that it's something that you're pretty common to, pretty familiar with, sorry. All right, let's go on. We had some different types of matrices. So these are column because they consist of one column. These are rows because they consist of one row. These are square matrices because the number of rows is equal to the number of columns in these. And even though they are all 2 by 2, they could have been 3 by 3 or 4 by 4, and they would still would have been square matrices. And these are null or zero matrices because they only have zeros in them, right? That's why I call it a null or zero matrix. This is a diagonal matrix because this is the main or leading diagonal, and there are numbers there. And in the other diagonal or the non-leading diagonal, there are zeros. So in a diagonal matrix, these numbers would always be zeros. All right, this is the leading diagonal here, and these are the other diagonals. Sometimes people call them the non-leading diagonal. And there's a special matrix, diagonal matrix, called the unit matrix. And we are supposed to be aware of these. The reason why this is an important one is because it is known as the identity matrix for multiplication of any 2 by 2 matrix. Because if you take a 2 by 2 matrix and you multiply it by this special diagonal matrix called the unit matrix, right, that matrix is unchanged. It's like multiplying by 1. So it's interesting to know that I times A is equal to A. Also, A times I is equal to A. If you multiply them in either direction, you're still going to get back the matrix A. So that's why it's called the identity matrix for multiplication. Now, there's a big term called formalizing a matrix, right? And all it simply means is that you remove anything else other than the number and you put brackets around it. So if they give you this information here that these people here went shopping and they brought the items given in the table below, and they ask you to formalize a matrix to show this, right? All it means is take all this information away and simply write down the numbers and put 2 brackets around it. That's called formalizing the matrix. All right, so very simple. All right, the last thing that we're going to look at is addition and subtraction of matrices. So what does it say? Matrices of the same order can be added or subtracted by adding or subtracting corresponding elements, right? It's actually, this is not the last thing because we still have to do scalar multiplication. So we'll come down to that just now. All right, so you cannot add matrices if they are not of the same order, right? And you must add corresponding elements. So for example, if I want to add A and B, right? I have to add the 5 and the minus 2 together, the minus 7 and the 4 together, the 8 and the minus 1 together, and the 3 and the 3 together. That's how I will add these matrices together. So 5 would be added to minus 2 like this, minus 7 to 4, 8 to minus 1, and 3 to 3, right? But remember, when you have a plus outside a bracket, it has no effect on it. So it's the same thing as saying 5 minus 2. This is still here. Plus has no effect, so it's the same thing as 8 minus 1. And then you work it out. 5 take away 2 is 3. Negative 7 and 4 is negative 3. 8 minus 1 is 7, and 3 plus 3 is 6, right? Simple. But here now, you wouldn't believe how, sometimes very smart students get these type of questions wrong because they are complacent, right? Complacent meaning they take it for granted and they forget simple rules. So like, for example, A minus B would be 5, right, minus 2, like that. A minus B is this, so it'd be 5 minus 2, minus 7 minus 4, 8 minus 1, and 3 minus 3. Notice it's corresponding, this with this one with this with this one, and this one with this one. They're corresponding, so you be careful what you're working with. And then when you have minus, remember that the minus will reverse the sign. It changes it, so it becomes a plus. See? Similarly here. Okay? And 5 plus 2 is 7. Negative 7, negative 4 is negative 11. 8 minus 1 is 8 plus 1, which is 9. And 3 minus 3 is 0. Okay? So I'm gonna ask you to do something, right? Seeing that I've been talking for so long and I want to give you a little practice here. So could you try for me very quickly. I'm going to write it here for you so you will see it. And it should take you a short time. Could you try for me C takeaway B? All right, you'll try that quickly for me. C takeaway B, and I will give you the answer in about 3 minutes. All right, take a quick work on it. You could do it in any scrap you have there, and let's see what you get. Right. So I asked you to do C takeaway B. Right. I'm hoping that you guys were able to do it. So I'm going to do it now for you, and you can see how you went, right? So C takeaway B. So I wrote down C takeaway B, but the first thing I'll do before I go through the calculation is to make sure that I wrote down the numbers correctly, right? Because a big problem at times is writing down the numbers that are not actually in the question. So C was 1, 0, minus 1, 2, right? So I wrote down that one correctly. I have to take away, so the takeaway sign was correct. And then B now is minus 2, 4, minus 1, 3. So I was accurate in transferring the information, right? And then now to do the actual subtraction, it will be the 1, right? This one here, take away minus 2. So it'll be 1 minus minus 2. And 1 minus minus 2 is 1 plus 2. So that's what should go in that first position. Then I'm going to deal with the 0 and the 4. So that'll be 0 take away 4. Let's write it down, 0 take away 4. Then I'm going to deal with the minus 1 and the minus 1 here. So that'll be minus 1 minus minus 1. Okay? Minus 1 minus minus 1, which will be minus 1 plus 1. Okay? Minus 1 minus minus 1 is minus 1 plus 1. And then finally, I'm going to deal with the 2 here and the 3. So that'll be 2 take away 3. All right? And once you take your time and get it into that order, you should be okay. So the first element will be 1 plus 2, which will be 3. The second one will be 0 minus 4, which is minus 4. The third one will be minus 1 plus 1, which will be 0. And the last one will be 2 minus 3, which will be minus 1. All right, so I hope you all were able to get that. All right, and we go to the next one now. Here we are looking at scalar multiplication as opposed to matrix multiplication. In scalar multiplication, we multiply the matrix by a number as opposed to matrix multiplication where we multiply one matrix by another. Okay, that's a separate thing we'll do in the next class. In this class here, we're looking at simply multiplying a matrix by a number. And the only thing we have to remember is that if this here represents a number, let me just get back to the arrow. Just 1 second. Right? If k represents a number, then k times a, b, c, d means that the k has to multiply by each element in there. So the k has to be multiplied by the a to give you ka, k by b, kb, k by c, kc, k by d, kd. In other words, then whatever is on the outside, even if it's on the left or on the right, it doesn't matter. It has to multiply by everything inside of there to give you this result. So let's look at these, for example. In A, given that A is this number and K is this number, if we have to find KA, it means that 4 has to be multiplied by this matrix A. Okay, so that means that 4 has to be multiplied by each element in there. So the 4 has to be multiplied by the negative 2. The 4 has to be multiplied by the 1, 4 by 5, 4 by 0. Okay, so 4 by negative 2 is negative 8. 4 by 1 is 4, by 5 is 20, and by 0 is 0. So this will be the answer for that, right? This one is a little different because there's a combination of actions or operations involved. So it'll be 2 by p minus q. But recall what p is, 6, 5 minus 3, 4, right? So 6, 5 minus 3, 4. So 2 by p will be 2 by this minus q. What is q again? Q is 2018, 2018, right? And then you proceed from there. So let's see. 2 by 6 will give us 12. 2 by 5 will give us 10. 2 by negative 3 will give us negative 6. 2 by 4, 8. Right? So that's this calculated here. And the minus 2018, minus 2018, minus 2018. If we're not using it for ease of good statement, we just keep it until we're ready to deal with it. So we're ready to deal with it here now. So because both of these are 2 by 2 matrices, it means that we could add them or subtract them, you know, from one another. In this case, it will be 12 take away 2. It'll be 10 take away 0. That'll go here. It'll be negative 6 minus 1, which is here, and 8 take away 8. All right? So 12 take away 2 is 10. 10 take away 0 is 10. Minus 6 minus 1 is minus 7. And 8 minus 8 is 0. All right? You guys always get in the habit of working these things mentally. Don't take a calculator and punch in and get your answer for these simple calculations. One main reason you should always be mindful of is that you guys have to do a multiple choice, and the multiple choice weighs heavily now. In the multiple choice, you cannot use a calculator. So do not practice using a calculator for these type of questions, which could come in the multiple choice. Or another way to say that is to practice using no calculator. Practice it using your mind alone, right? Or pen and pencil alone, and get your answers, right? So that you'll get in the habit of doing the things that you will have to do when you sit the exam. All right. Now, in this case, there's a half P minus a quarter Q. Sometimes people get a little flustered, you know, because you have to deal with fractions. So let's see, if you have to deal with fractions, what do you do? Well, P was this, Q was this, and you just put your fractions in and let's multiply, right? A half by 6 means a half of 6, which is 3. A half by 5 means a half times 5. A half of 5 is 2.5. Or if you wanted to put 5 over 2, you could. A half of -3, you multiply a positive number by a negative number. The signs are unlike. So that means that the answer is going to be negative. So I know I'm going to get a negative answer here. And a half of 3 is 3 over 2, or 1.5, which is this, right? So it's -1.5. A half times 4, or half of 4, is 2. That is this here. So that gives me this one, right? Minus a quarter times 2 is 2 times minus a quarter, like this. The 2 will cancel into itself one time and will go into the 4 2 times. So this will end up being a half when you do the calculation, which is this, right? A quarter times 0 is 0. A quarter times 1 is a quarter. A quarter times 8 means this 8 is going to be divided by the 4. So 4 into 4, 1, 4 into 8, 2. You're going to end up with 2 here, all right? And then 3 take away a half will go on top. 2.5 take away 0 will go here. -1.5 minus a quarter. Remember, you have to be dealing with corresponding elements. So -1.5 minus a quarter will go here. And then 2 minus 2 will go right here. All right. So remember, you have to work with corresponding elements. What will give people trouble is this calculation here more than anything else. The rest should be easy, right? So 3 take away a half is 2.5. 2.5 minus nothing, 2.5. 2 take away 2 is 0. And this is the one that might give you a little trouble. So I'm going to work it here for you, because remember, you have to do this without a calculator, right? So let's do. So we have, let's work, this is what we work in here, right? So we say -1.5 minus a quarter. So we could convert it, right? We could say 2 by 1 is 2 plus 1 is 3 over 2. Right? You could do it that way. Right? So 1.5 is the same thing as 3 over 2. So that's what we did there. And then we could do LCM of 2 and 4 is 4. This is a negative, right? So it'll be 2 into 4, 2. 2 by 3 is 6. Minus, right? Minus 4 into 4, 1. 1 by 1 is 1. So you're ending up now on top with -7 over 4, right? And that's the same thing as -1 3/4, because 4 could go into 7 one time, remainder 3. So -1 3/4. So let's go over that quickly so that you will feel a little more comfortable. So this is -1.5 minus a quarter, right? 2 ones are 2 and 1 is 3. So you get this 3 on top over the 2, and it's a negative sign, minus a quarter, right? And now the 2 and the 4, the LCM will use as 4. So we say 2, this 2 here into 4 will be 2 times 3 will give me 6, but there's a negative sign, right? So we keep that there. This negative sign is here. And 4 into 4 is 1. 1 times 1 is 1. So you have -6 minus 1 is -7 over 4. And then 4 could go into 7 one time, remainder 3. Right? And you're dividing by 4. So this is 1 3/4, but it's a negative answer because you're dividing a -7 by a +4. And when you divide unlike signs, the result is going to be negative. So this -1 3/4 is what actually comes here. All right. So what I wanted to do for you is I wanted you to try this one here for me. Right? Try this one here for me. It's 3Q plus a half P. 3Q plus a half P. So I'm going to show you back what P and Q are so you can get it, right? Look, so here's P and here's Q. So I would like you now to work out for me what is the answer for this question, 3q plus a half p, right? That's what I want you to do for me. So work on that for me now. I'll give you about 4 minutes to work on it. 3q plus a half p, right? No calculators. Working without calculators, see what you get. Okay, so we are looking at the solution now right, for that question that I gave you. So let's look at it here. It was 3q plus a half p, right? 3q plus a half p. So let's look and see if I transferred it correctly. 3q will be 3 times 2018, 3 times 2018, plus a half p. A half, what is p? 65 minus 34, 65 minus 34. So I transferred it correctly, and so I can proceed, right? So you always do that. Make sure you transfer it correctly from your script to your paper or wherever you're doing your calculation. So then we multiply the 3 by every element. So 3 by 2 is 6, 3 by 0 is 0, 3 by 1 is 3, 3 by 8 is 24. Then I'm going to add a half times 6 is 3, a half times 5 is 5 over 2, a half times minus 3 is minus 3 over 2, a half times 4 is 2. So now I'm going to do the addition, right? 6 and 3 is 9. 0 and 5 over 2 is 5 over 2. 3 plus minus 3 over 2 is the same thing as 3 minus 3 over 2. And 24 plus 2 is 26. So this is what we end up with, right? So 9, 5 over 2, 3 minus 3 over 2, and 26. Well, let's do 3 minus 3 over 2 here. 3 minus 3 over 2. We put the 3 over 1. The LCM, well, you could do LCM, or you could notice that 3 over 1 is the same thing as 6 over 2. It's called equivalent fractions. So what I did was multiply the top and the bottom here by 2. So 2 3s are 6, 2 1s are 2, like this, because 3 over 1 is the same thing as 6 over 2. But why I did that is because once these numbers are the same, that is the denominators are the same, then all we have to do is work with the numerators. So it'll be 6 take away 3, which is 3, over whatever this is, 3 over 2. So that's another method you can use if you didn't want to use LCM. You could use the equivalent fractions method. And so 3 over 2 would be the result of this calculation, which comes here, and therefore 3 over 2. So you can leave the answer like this, or if you want to go a little further, you could write that 5 over 2 is 2.5, and 3 over 2 is 1.5. So this would be the answer for that. All right. So that would basically close off your matrices for this session. But I just wanted to go back up quickly to this here. I didn't mention something to you that I wanted to, and I'll do it now. Right. And what it says is that when we are doing the cumulative frequency calculations, the graphs and so on, we said that when you have these words, the words more than, right? Let me widen here a bit so we can see it better. Right? When you have the words more than or no more than, we said that that tells us to use the upper class limits on the x-axis when these words are in the question. Similarly, when these words or their equivalent, or you could interpret from the information these words or their equivalents, then we know that we're going to use the upper class boundaries when we're doing our calculations and our drawings, right? That is option 2. But what we didn't mention is if in the questions you are not seeing any of these words or their equivalent meanings, or words with their equivalent meanings, or anything that you could interpret with logic to bring to these words, to the same meanings of these words, if none of those things are occurring, then how do we make a decision as to if we're going to use 1 or 2? We're going to use this upper class limits or upper class boundaries. And the answer is simply that the default position, right? Default meaning if none of the words or their equivalents are present. If none, what is the default if none of these words are present? Right? And the answer is that the default is going to be this guy here. Okay, but you must do a thorough examination to ensure that you cannot pick up any one of these words or their equivalents, meanings with their equivalent, or logic to bring to bear the meanings of these words. Once that is not possible, the default that we will use, or the one that we will use, will be case number 1. All right, I didn't mention that to you before, so I thought I would bring it back into the discussion. All right, so that would bring us to the end of tonight's class. We have been going for about 2 hours now, right? So that'll bring us to the end, right? I hope that it was useful for you guys. I'm glad to see you all held on right down to the end, all right? And so I will post this up on our YouTube channel. I'll put the link so you can go back if you missed anything, and you can go right there and get this tutorial together with all the other tutorials that I have done so far and the past paper solutions that I have done as well. All right. In the last session, I had I had given you all June paper 1, and I ended up doing Jan paper 1 for 2014. But what I did was I posted the Jan past paper afterwards in the WhatsApp chat, so you can get it and then go to the link that I sent to get the solutions. All right, I will send you another past paper soon, and we will look at the solutions for that probably on Thursday. All right, so that's it for now, you guys. So God bless, and I'll see you all for the past paper class that will be later on this week, right? Probably around Tuesday, as I mentioned.
Bye. Good night, everybody. Good night, sir.
Okay, take care.
Bye.
Okay, bye-bye.
All right. Good night, sir. Bye.
Bye-bye. Take care.
Bye, sir. You too.
Okay, God bless.
Mm.